Let's look at question number 21. What is the app service plan and how does it affect performance and cost? We kind of touched on app service plan when we talked about what is Azure App Service. So let me populate the short answer first, then we will go into the explanations. First, let's understand what is app service plan. An app service plan determines the pricing, performance, scalability of your application service. And it defines the region. Region is nothing but a data center of the physical server where your application service is hosted and the number of resources. These resources are nothing but CPU, memory, and storage allocated to your application. What you see here on the screen right now below this is the app service plan tiers. So if you remember when we looked into the virtual machine, I showed you different types of virtual machines you can pick, and each virtual machine is created for a specific purpose and each have a different cost associated with it. Similarly, in app service, these are all the plans available. So let me take you through this one by one. The first one is free or shared F1D1. So this is useful for any sort of basic hosting for testing purposes or ideal for any sort of low traffic applications and development environments. Next, we have the basic tier. Basic tier is suitable for small scale web application with manual scaling. This offers you moderate performance with limited features. Then comes the better plans. So when you go tier higher, the performance will increase and the feature set will increase too. Next is the standard one. This provides auto scaling. So if you remember, I talked about the basic one. Here you will have to manually scale, but in the standard one, we have an option for auto scaling and you have extra load balancing capabilities. That makes it appropriate for any sort of production workloads. Next, we have the premium P1 version 2, P3 version 2. This provides you advanced performance, faster scaling, and additional networking features. This is perfect for high traffic applications and enterprise level solutions. And the last tier is isolated. This is usually for any sort of private dedicated environment for high security applications. This ensures that full isolation and compliance with regulatory requirements. So these are some of the tiers. So if you want to understand other aspect of it, if you go back to the previous questions, I kind of mentioned about the benefits of app service plan, including the scalability, flexibility offers. So let me quickly talk about some of the example and use cases. For development and testing, they probably use the free tier and the standard tier for building and testing new application without incurring high cost. Small business websites typically use the basic and free tier for an economical option for hosting small business websites. I don't think they will use the free tier, so they will particularly stick with the basic tier for small website hosting. And enterprise use this premium and isolated plans that are ideal for hosting any sort of mission critical enterprise application with stringent performance and security requirements. Let's look into question number 22. Which of the following is not a feature of Azure App Service? We are doing a deduction to find which is not a feature of Azure App Service. Let's go through one by one. Serverless computing. Serverless computing is a feature of Azure App Service because Azure App Service utilizes serverless computing features like Azure Functions, which allows you to run code without provisioning or managing services. The next is built-in DevOps integration. That is also a feature because Azure App Service offers seamless integration with Azure DevOps, GitHub, and other CI/CD tools, facilitating continuous deployment and development. Third is automatic scaling. Again, Automatic scaling is also a built-in feature because Azure App Service can automatically scale up and down based on traffic, thus ensuring optimal performance and cost efficiency. So the wrong answer, which is not a feature for Azure App Service, is managed virtual machine. Managed virtual machine is part of an infrastructure as a platform service. Azure App Service is a platform as a service. So that concludes the Azure App Service section. Next, we are going to look into 3 questions on Azure Kubernetes Service or AKS. Let's look into the question number 23rd. What is Azure Kubernetes Service or AKS and why is it used? So if you don't know, let me populate the short answer, then I will give you the explanation. On a super high level, Azure Kubernetes Service or AKS is a managed Kubernetes service that simplifies deploying, managing and scaling containerized applications in Azure. And this comes with a lot of features and functionalities. So let me take you through this one by one. Why would you use AKS or Azure Kubernetes Service? First point is managed Kubernetes ability. Azure handles the updates, scaling, security, so you can focus on your application development. Next, cost effectiveness. So you can only pay for your virtual machines and not the control plane for making it the cost efficient solution at all. So you don't worry about the management layer. Azure will provide that for free. You only pay for the backend virtual machine where your AKS instances are running. Additionally, AKS or Azure Kubernetes Service provide you built-in monitoring capability, and this is integrated with your Azure monitoring and log analytics services, thus providing a robust monitoring insight. And next feature why it can be beneficial to use AKS in Azure is the scalability aspect of it. AKS can be built to automatically scale pods and nodes based on the demand, ensuring your applications run effectively under varying loads. Some of the other features which I can talk about is the high availability options, security, and the flexibility. Some of the use cases which you can think of is you can use AKS for development and testing, and by quickly spin up and manage isolated environment for development and testing. And it is ideal for deploying microservices based application, which allows for independent scaling and management of these services. AKS can be used for batch processing. It provides you an optimal resource utilization, or you can use it for high available applications as well. Let's look into question number 24. This is a scenario based question. Let's read out the question number 24. Your team needs to deploy a microservices based application with high availability and auto scaling. How would Azure Kubernetes services help? So key points here is microservices based, high availability and auto scaling. So let's populate the short answer. To ensure high availability and auto scaling, you can use Azure Kubernetes services these features. So these are some of the features which are offered by AKS for high availability and auto scaling. So let's take you through one by one. Horizontal pod autoscaler or HPA. This automatically increases or decreases the number of pods based on observed CPU or memory usage. And this ensures that your application can handle varying loads efficiently. The next feature is cluster autoscaler. If you use cluster autoscaler, this will adjust the number of worker nodes in your cluster based on the demand of your workloads. And this will help in optimizing resource utilization and reducing cost. Another feature you can highlight is load balancer and ingress controller. If you use this feature, this will help you distribute incoming traffic across multiple pods, which will ensure no single pod becomes bottleneck. And this enhances the reliability and availability of your application. And the next feature is the node pools. This allows you to run different types of workloads on different VM sizes within the same cluster. This provides flexibility in managing resources and optimizing performance. So use these high-level features to talk about why you should be looking at Azure Kubernetes Service to help deploy this microservice-based application with high availability and auto scaling. Additionally, you can talk about some of the use cases which we mentioned before, like development and testing, microservices, batch processing, high availability applications, things like that. Question number 25. It's a multiple choice question. Which of the following is not a feature of Azure Kubernetes Service? We are going to go through the detection method we used before. First, is it not a fully managed control plane? I kind of explained that at the beginning. AKS provide you with a fully managed control plane so that you only pay for the backend virtual machine, you don't pay for the control plane. So that is definitely a feature of AKS. Second is built-in support for container orchestration. 100% AKS have all the features and tools and mechanism in place to support the container orchestration by default within the service. The next is automatic application deployment without configuration. That is the wrong answer because AKS provide infrastructure management, but the application deployment require configuration via Kubernetes manifest or Helm charts. So it doesn't provide you automatic application deployment and configuration. So that is something you need to keep in mind. And the next one is, does it integrate with Azure Monitor and Azure Security Center? 100% yes. That provides you with rich insight and intelligence into how these services running. And Azure Security Center offers you additional security around these Azure Kubernetes service microservices as well. In the next section, we are going to go through 3 questions on Azure Functions. Azure Functions is a serverless computing offering. Let's go through that. Question number 26. First and foremost, what is this Azure function and how does it support serverless computing? Let's populate the short answer. Azure Functions is a serverless compute service provided by Microsoft Azure, which allows developers to run event-driven code without the need to explicitly manage or provision infrastructure. This means that developers can focus on building and deploying their application without worrying about the underlying server management. So that is the main key benefit. It's like a code as a service. Some of the key features of Azure Functions include automatic scaling, pay-per execution, multiple triggers, and it has integrated security monitoring and things like that. So you need to sprinkle in these key features explaining about that in detail. Let's look at question number 27. Your application need to process images uploaded to Azure Blob Storage automatically. How can Azure Functions help? So this is a scenario based question. So you can explain this by telling Azure Function can automatically process uploaded image using an Azure Blob Storage tier. How? You can use things like trigger, processing, storage notification, things like that. So there is something called trigger within Azure Function. And when you use trigger, the function runs whenever a new image is uploaded to a specified block container. Then there is a option called processing. And the function can resize, compress, or analyze the image based on that processing. And finally, you can use the storage and notification for processed image can be stored in another location, and a notification can be sent for telling you that that job is done or that job is failed, things like that. So how do you explain the answer? So you can probably tell by explaining like an example. A function is triggered when a new image is uploaded to a designated blob storage, and then the function can perform various processing tasks on the image such as resizing, compressing, or analyzing. And then after processing the image, it can be stored in a different location, and additionally a notification can be sent to inform the user or the system about the completion about the processing task. Let's look into question number 28. Which of the following billing model does Azure Function use in the consumption plan? We are doing a detection here. First, let's understand what is this consumption plan. In the consumption plan, you only pay for the time your Azure function runs based on the execution count, memory, and the execution time. This model provides great flexibility and cost efficiency for applications with varying workloads. So let's look at these options. Pay for reserved virtual machine. That's a wrong answer because that's a virtual machine service to reserving your instances to reduce cost. Pay for memory allocation only. There is no option like that. Pay for number of execution and execution time 100%. In the consumption plan, you only pay for your time of your function runs based on the execution count, memory, and the execution time. And pay a flat monthly fee. That is a wrong answer. So the correct answer is pay for number of execution and execution time. So what are some of the use cases of Azure Function? You can use it for event-driven application that require any sort of process based on specific triggers, or you can use it for background tasks such as image processing, data transformation, and file conversions, or you can use it for APIs and microservices architecture where functions are invoked in response to HTTP request. The next one is Azure Virtual Desktop. We have 8 questions to go over that. Let's go through this one by one. What is Azure Virtual Desktop or AVD and how does it work? Here the interviewer is trying to understand your knowledge on what is AVD and give some use case scenarios on how it works. Let's populate the short answer. So you can explain Azure Virtual Desktop as a cloud-based desktop and application virtualization service that enables secure remote access to virtual desktops and apps from any device. It can be a mobile device, it can be your laptop, it could be Windows 10 or Windows 11 or a Mac operating system. And this provides a comprehensive solution for organizations looking to offer their employees a flexible and secure way to access their work environment from anywhere. That's what Azure Virtual Desktop is. And I'm sure many of you already know about it. The important thing you need to help them understand is the key features of Azure Virtual Desktop. So these are multi-session, optimized for Microsoft 365 apps, its security and integration with FS logics. So let me help you understand these features one by one. First, let's look into multi-session. AVD allows multiple users to share the same virtual machine, providing a scalable and cost-effective solution. That is what we call multi-session in Azure Virtual Desktop. The second feature is optimized for Microsoft 365 apps. So this seamlessly integrates with Microsoft 365 applications such as Word, Excel, and Outlook, ensuring a smooth user experience. Third feature you can highlight is secure remote access with Azure AD or Entra ID authentication. So you can utilize Entra ID for authentication and access control, ensuring secure connection to your virtual desktop. Only the right users will be able to sign in and use the Azure Virtual Desktop. And another feature is integration with FS Logics for user profile management. So as you already know that AVDs allows you to use FS Logics technology. So when you use that, it allows you to store user profiles, providing a consistent and seamless experience regardless of the device you use to access the virtual desktop. Additional feature you can highlight is the application virtualization part of it, and just throw in some of the benefits of Azure Virtual Desktop, which include flexibility, cost efficiency, and things like that. So where would you typically use this Azure Virtual Desktop? So if they ask about some of the use cases, you can tell that Azure Virtual Desktop or Windows 365 are used in remote work, which enables employees to securely access their work environment from home or other remote locations. Second is temporary staff. This allows you to quickly provision a virtual desktop for temporary or seasonal workers without the need for additional hardware. Another use case is disaster recovery. This provides a reliable backup solution, ensuring business continuity in the event of a disaster. Or you could use AVD for any sort of development and testing as well. Let's look into question number 30. The interviewer is trying to understand, do you know what are the key components of AVD or Azure Virtual Desktop deployment? So when you try to deploy AVD, what are the things you need to be aware of? So let's populate the short answer. When you try to deploy Azure Virtual Desktop, you need to be aware of these terms and these services like host pool, session host, Azure AD, identity services, FS Logic profile container, and network connectivity. So let me take you through one by one. First, what is this host pool? Host pool is a collection of virtual machines that host Windows 10 multi-session or Windows 10 single session or Windows 11 multi-session or Windows 11 single session or any server remote desktop services or applications as well. So it's a bunch of machines that you are trying to host your service. Next is session host. These are the virtual machines within the host pool that users connect to in order to access their desktops and applications. Next is, what about Azure AD Identity Services? This provides essential authentication and access control integrating with your on-prem services or your Azure AD for secure login. We already mentioned about FS logics and profile containers. This is used to store the user profile. When you do that, this will ensure that the users have a consistent and personalized experience, whichever device they use to sign in. And last but not the least is the network connectivity component. You can utilize Azure VPN or any other VPN to integrate with on-premises environment, ensuring robust and secure connections. So each AVD deployment consists of these several key components. When you deploy it, it works together to deliver the seamless virtual desktop experience. All of this is kind of working together hand in hand to make the experience user friendly and maintaining the service availability of the service.